Alright, so let's start. So in the previous discussion of radioactivity, we talked about Kiki. Let's just do a quick review of what we did talk about. We talked about the atomic model, the nuclear model of the atom, where Rutherford's experiment, Geiger and Marsden, right? They found out the structure of the atom wasn't the plum pudding. It was actually the nuclear model where you had a highly dense and charged nucleus, which was most of the mass, and the rest of the atom was mostly empty space, and there were some electrons in the orbitals, right? Now we talked about atomic mass, atomic number, right? We talked about isotopes. Then we also talked about the concept of nuclear fusion and nuclear fission, right? Then we talked about the different types of radioactivity, which is alpha, beta, and gamma. They're all key ionizing radiations, right? Quickly, kyo bolo to alpha composition key. Quick, 2 protons, 2 neutrons, right? Beta composition key, 1 electron. Gamma, electromagnetic radiation. ठीक है sir. Alpha charge plus 2. এত তাড়াতাড়ি বলেন, এত স্লো বলেন, তাড়াতাড়ি বলো না কেন? সরি আর ইলেকট্রন কতই? -1. ঠিক আছে। গামা 0. আয়নাইজিং ক্যাপাবিলিটি সবচেয়ে হাই কার? আলফা। পেনিট্রেটিং ক্যাপাবিলিটি সবচেয়ে লো কার? আলফা। ঠিক আছে। Anyway, so yeah, alpha is stopped by a thin sheet of paper or 4 to 10 centimeters of air. Beta is stopped by several meters of air or a few millimeters of aluminium or any metal. Gamma is decreased by a few inches of lead or a few meters of concrete. Most ionizing is alpha, least ionizing is gamma. Tomodere comparative yegulo jana thakte hobe, right? Etok to jano. Then we also talked about how they deflect in electric and magnetic fields, তাই না? All right. Today we are going to talk about, and we also talked about the equations, right? Alpha, beta, gamma, J equation, decay equation, plus we talked about this. Today we're going to talk about the concept of half-life. All right. So we have to understand what goes on when we talk about half-life and all of this. So let's see what's written here. Use the term half-life in simple calculations which might involve information in tables or in decay curves. Take a sip. And calculate half-life from data or decay curves from which background radiation has not been subtracted. So we have to understand the concept of background radiation also. So let's start with that. Let's first start with the concept of background radiation. Take a sip. So background radiation theke amra ki jani? Basically, what we know is even if you don't have a radioactive source, so how would we define background radiation? Hello? Lol. That is always yes, it is a radioactivity or a detectable radiation which is present even in the absence of any apparent radioactive source. So, ekhane absence of what? Apparent radioactive source. So that means what? Apparent money with the say there's an obvious source. So there is no obvious source here in the absence of any obvious radioactive source. That means there are sources. You're just not being able to see them, right? So it won't the background radiation is basically a GM tube. GM tube to shobai, you've heard the name, right? Geiger-Müller. So a GM tube is basically a device which is used to measure any sort of radioactivity. So kemne measure kore? Basically it's this device which picks up ionizing radiation and it causes clicks. ঠিক আছে মানে এখানে conduction যখন হয় ionization হওয়ার পরে conduction causes clicks and these clicks can be picked up by a counter. ঠিক আছে so the counter is basically the counts per minute. So what we do is we can point it at a radioactive source আর তখন কি radioactive source থেকে যা আসে ওইটা আমরা detect করতে পারবো. So without any obvious radioactive source, even if we take a GM tube and point it right now in this room, তুমি কি পাবা? You're going to get a counter. So what does this mean? This is the idea of background radiation. So sources ki hobe. Number one source jeta amra bolte pari is cosmic radiation, right? Cosmic radiation includes radiation from the sun. So cosmic radiation jokhon hobe basically from the sun and other stars, like from different places in space. So usually eta ki dhoroner radiation hobe? What does your common sense dictate? Alpha, beta, gamma kunta hobe? Gamma hobe, right? Space you'll get alpha, beta, gamma shobi baba karon ekhane to vacuum shob kisui travels long distances, but alpha and beta would be stopped by the outer layers of the atmosphere, right? Outermost layer ei shob atke jabe. So tomar kache ja ashbe hobe hoiteche mostly of it would be gamma, আর অন্য কিছু আসলেও that's going to be because of the gamma ionizing some other matter or the alpha beta ionizing matter high up in the atmosphere. ওটা directly তোমার কাছে আসবে না, যাই হোক এই এটা গেল one of the sources of background radiation. আরেকটা সোর্স কি হতে পারে? Naturally occurring radioactive substances. ঠিক আছে সো এটা মানে হইতেছে যে যেরকম ধরো তোমার কলার মধ্যে যেরকম পটাশিয়াম, ঠিক আছে রেডিওঅ্যাক্টিভ পটাশিয়াম যদি থাকে, বা গাছের মধ্যে কার্বন 14, ঠিক আছে সো বা লাইক কার্বন ইন দ্য ব্রিক্স অফ ওয়ালস এন্ড এভরিথিং, বুঝছো এরকম কয়েক জায়গায় ইউ উইল গেট ন্যাচারালি occurring radioactive substances. Do you get that? এটা গেল। আর কি হতে পারে? Yes, nearby hospitals and power plants. ঠিক আছে, hospitals and power plants. এটা তো বুঝছো, nearby hospitals and power plants can also be a source of background radiation. So background radiation count is approximately, you could say it's around 20 counts per minute. So এটা কিন্তু কোনো guarantee নাই যে হ্যাঁ exactly 20 counts per minute. Can anyone tell me why we can't guarantee an exact value?
Because radiation is random.
Yes, radioactive decay, not radiation, radioactive decay is a purely random process. You cannot predict when a particle will decay. ঠিক আছে, বা ধরো এরকম you have a collection of radioactive particles. It is impossible to predict কোনটা বেশি করবে, কোনটা কম করবে, কোনটা আগে করবে, কোনটা পরে করবে, right? And you cannot either predict ওইটা যদি হতো, or even if you had just one radioactive particle, when it will decay.
You said particle.
I didn't. No, I didn't.
You did.
What's a particle?
Particle.
Muni Flavi.
It's being recorded.
I'm gonna delete this.
No.
Please don't.
Please don't. So the show. Jai Ho. Next point.
Point.
Point. So, it is a background radiation concept. Now we can go into the concept of half-life. All right. So I would like you guys to pay attention. Half-life concept. It's very easy if you know how to deal with it, but if you don't, then it's a little difficult. So half-life is a concept. It's a fairly straightforward concept if you pay attention. So first we're going to talk about an analogy, then we're going to compare it to the real situation. All right. One analogy would be, say we take a beaker, or a long graduated cylinder. Oh my God. So we take a long graduated cylinder, and I don't want to say there's this like a small hole here or an exit, like a tap. You can pour out the liquid. So you fill up the liquid to the top, water they fill up kola, and you allow the water to flow out. And what's going to happen is, over time, it will flow. After a certain amount of time, say 2 minutes. After 2 minutes, you're going to see it's going to drop to say half. All right. After another 2 minutes, where do you expect it's going to be? Well, a common mistake might be that it's going to be empty, but actually, hobe na ki hobe 8.5. So why is it that or shomoy aro mane slow? Why is it slowing down? Because it's water. It's because of the pressure. So এইরকম আর কি, যে as it goes lower down, the rate of flow decreases. তখন গিয়ে তোমার আস্তে আস্তে এটা নিচে নামতে থাকে। আর একটা হতে পারে you can take it to half of this. ঠিক আছে, মানে another 2 minutes পরে। Do you get it? So this is at 2 minutes. This would be at 4 minutes. This would be at 6 minutes, right? Therefore, it would be here at say 8 minutes. Do you get it? So basically, we could define this 2 minutes as the time required for whatever substance you start off with to drop to half of that amount. So even if ধরো এটা stopwatch এখান থেকে শুরু হইলো, তারপর ধরো নামতেছে, তারপর হঠাৎ করে ধরো আলিফ এসে বললো, হ্যাঁ আমি তো করি না এক্সপেরিমেন্ট, আমি এখান থেকে শুরু করি। ঠিক আছে। সো আলিফ ধরো এখানে এসে হি স্টার্টস হিজ stopwatch, ঠিক আছে, এখান থেকে স্টার্ট হলো। এটার অর্ধেক যে জায়গায় হবে, ঠিক আছে, which is around here approximately, সে দেখবে 2 মিনিট পরে এটার অর্ধেকে চলে আসবে। Do you get it? So it doesn't really matter where you start from. Basically, this is the concept of what is the idea of half-life. That is the time required for it to drop to half of its original amount. And the interesting bit is that whatever value you start from, it will always end up at that value, right? Take us money, half of that value. So I'm going to want a graph aquí. Graph might be like this. Take us. So এটা ধরো অর্ধেক হবে এইখানে, right? So এটার অর্ধেক would be somewhere around here. আমার গ্রাফ হয় না ঠিক মতো। So basically এই টাইমটা should be equal to this time. Do you get it? So এইরকম। ধরো আমি কাজ করি, half life এর গ্রাফ বাই করি। So here is a good example of what we're talking about. If you start off with 100 particles, ঠিক আছে, তাহলে what's going to happen? After a certain time, ঠিক আছে, say 5 minutes, it's going to drop down to half of that value. Does this make sense? Again, after say another 5 minutes, it's going to drop down to half of that value. So 10 minutes. Do you get it? So after another 5 minutes, 15 minutes later, it's dropping down to half of that value. So here, if we take radioactive particles, the red dots, these represent particles which have not decayed yet. Take a sip. When they decay, they become, say, gray. So number one, this also represents the random behavior of radioactive decay, because you cannot predict, there's no pattern that these particles follow. Is this making sense to you guys? So this is basically what we're seeing here. So এখানে say how many half-lives do we have here? We have 0 half-lives. ঠিক আছে, time is equal to 0 minutes. Half-life কয়টা গেছে? 0. এখানে time আমরা বলতে পারি is equal to 5 minutes. কয়টা half-life গেছে? 1. এখানে 1 লেখা আছে, I won't write that again. How much substance are you left with?
50.
Half. ঠিক আছে, আবার time ধরে এখানে হইতেছে 2 তে time হইতেছে কতক্ষণ? 10 minutes. তাহলে এখানে কি কত হবে? 1/4, which is also written as 1/4, can also be written by 1/2 to the power 2, right? তারপরে এখানে this is equal to say কতক্ষণ? 15 minutes. So 15 minutes যদি হয় 3 half-lives, right? কতক্ষণ থাকবে? 1/2 to the power 3, which is basically 1/8. And again এখানে t is equal to কতক্ষণ? 20 minutes, right? So এখানে কি কত হবে? 1/16, which is basically 1/2 to the power 4. So যে এই জিনিসটা, this is an easy method to remember it by. এটা কিন্তু keep in mind, you can't write this. তোমার লেখার সময় তোমার সুন্দর করে progression করে লিখতে হবে. At 1 half-life, half of the substance is gone. At 2 half-lives, 10 minutes, 1/4 of the substance. At 3 half-lives, 1/8 of the substance. This is just an easy reminder. Amount left can be basically key 1/2 to the power n, where n is what? Number of half-lives. Does this make sense to everyone? There's this really important thing here. The number of particles which are radioactive are decreasing. So basically they decay and leave. So this is why the activity is decreasing. Half-life er sathe, why is it that এটা সোজা করে নামে না কেন? That's a very common question. Like, why does it even curve like this? The reason is the rate of decay here is going to be faster because you're starting off with more particles. So when the particles decrease, the probability of decay is the same. So the number which can decay is less now. Okay, let's go to the second analogy that I would like to use to explain half-life concept. Second analogy is, we talked about water here. The next analogy is a box of coins. So we take a box and we put coins into it, all right? Bunch of coins and everything, blah, 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 blah.
Oh, yes.
And the coin has either a head or it has a tail, right? So what you do is you fill up the box with coins, you shake it, and then you pour out the box of all the coins on a table. What you do is যতগুলা head আছে ওইগুলা সরায় ফেললা, আর যতগুলা tail আছে you put them back in the box, ঠিক আছে? And then you shake it and you repeat this process again. You put them on the table, যতগুলা head আছে আবার সরায় ফেললা, আর যতগুলা tail আছে you put them back in. So according to basic chances probability, if you start with 1,000 coins, how many coins do you think will come up as heads?
5.
Half of them, right? Exactly to our 500 হবে না? A fraction of that, right? So a fraction of that would be, say, something around like 490, which is alright. Do you get what I'm saying? Doesn't have to be exactly 500. Abar you put these back in the box, you shake the box and then you pour it back out. তখন ধরো তোমার আসলো say 260. Are you getting what's going on here? So roughly half করে যাচ্ছে. তারপরে হইতেছে ধরো আবার করে ধরো আসলো তোমার কত? 120 আসলো. Do you get it? আবার করে পরে ধরো আসলো তোমার 50. So we're roughly going down to half with each time. So এটা তুমি যদি, if you were to draw a graph of this, তাহলে কি হবে? The number of times that you're shaking the box versus the number of coins. So say we start off with 1,000 coins. So 490 money, after one shake roughly half, after 2 shakes roughly half of that, 3 shakes roughly half of that, and then half of that. So you get a curve which is like this. So it would be a smooth curve passing through all the points. Is this making sense? So that's what happens with radioactive decay also. If you end up with say 260 coins, the number of heads will be less. The number which will be lost will naturally be less. If you start off with 1,000 coins, you'll come up with approximately 500 heads. Again at 260 you'll come up with approximately 120 or 130 heads. Do you get what's going on? So jeta karone the rate of decay will also slow down with time. Anyway, so we get this similar sort of behavior with half-life. So what is the easiest way to represent it or to understand it? Let's draw a short table to get what goes on. So first of all, let's take a substance. Say this is a substance and it is entirely radioactive. So etar half-life ধরলাম আমরা 1 hour. T half, the time required for the substance to decay to half of its original amount, this is 1 hour. So now we can say time elapsed, half-lives. Alright, so we have a table here which we've written up. Time elapsed, half-lives, amount left, amount gone, and that amount in 2 to the power n. ঠিক আছে? Which amount? Amount left. ঠিক আছে? We write that in 2 to the power n. And here we can draw a diagram. ঠিক আছে? Just to explain what's going on. So half-life আমরা ধরেছিলাম 1 hour. So time elapsed 0 hours. ঠিক আছে? এখানে hour দিয়ে দিলাম, so we don't have to write hour again and again. So half-life কয়টা গেছে? 0. Amount left কত? We consider this to be 1. Amount gone কত? 0. So this is 2 to the power 0. So left কত? 1. So this 0 is basically half-life এর ভ্যালুটা এখানে বসায় দিচ্ছি. So diagram মধ্যে we can call the entire substance. তারপরে say 1 hour passes. কয়টা half-life যাবে? 1 half-life. ঠিক আছে? Amount left কত? Half. Amount gone কত? Half. So this is 2 to the power 1. আর কতটুকু হবে? এর অর্ধেক. Does this make sense? তারপরে say 2 hours গেছে. 2 hours হলে half-life কয়টা গেছে? দুইটা. Really simple. So this is going to be 1/4 is left. Gone কত? 3/4 is gone. So this is 2 to the power 2. And this is basically 1/4. তারপরে say 3 half-lives. 3 half-lives হলে 3 hours, 3 half-lives. Amount left 1/8. Amount gone 7/8. And this is basically 2 to the power 3. So this is going to be how much? এরকম 1/8. একটু হবে something around this. Alright? And then say last আরেকটা বলি 4 hours গেছে 4 half-lives. How much is left? 1/16. How much is gone? 15/16. And 2 to the power 4. And this is going to be a small slice, basically 1/16. Does this make sense to everyone? So 8. So এরকম টেবিল করে এরকম ইয়ে করাটা it's important. So এখানে অর্ধেক চলে গেছে. এখানে don't fall under the misunderstanding যে এরকম সুন্দর করে অর্ধেক নাই হয়ে গেছে তারপরে কোণা চলে গেছে. It's like a disappearing pizza. ঠিক আছে? It's not like that. Like, you know, get that? Only Flavio? It's not a pizza. Anyway, pizza খাও না? Okay, we're not going to talk about that anymore. So is this clear to everyone? Okay, so this is how you do the half-life calculation. So let's just do a quick example of a half-life calculation, then we're done. So say there's a substance, ঠিক আছে? A radioactive substance. It count with say 500 counts per minute. ঠিক আছে? Do you get it? 500 counts per minute, including background. ঠিক আছে? So we don't know how much background is, but it's included in the 500 counts per minute. এটার half-life ধরো হইতেছে কত? Let's give it a value of 30 minutes. Alright? So the question is, what should be the count after 2 hours? So how are you going to do this? If it's including background 500 counts per minute, so ধরো ওরা আচ্ছা say first of all say ওরা বলে দিল যে background হইতেছে 20 counts per minute. তাহলে এটার actual count কত? 480. Alright, so 480. তারপর তোমার কি করতে হবে?
So 2 hours.
তোমার তারপরে বলতে হবে after t half 1, ঠিক আছে? Which is 30 minutes. কতটুকু থাকবে? এর অর্ধেক, which is 240. তারপরে হইতেছে t half যখন দুইটা তখন কতক্ষণ? 60 minutes. তখন 120. তারপরে হইতেছে t half তিনটা তখন কতক্ষণ? 90 minutes. 60. হ্যাঁ well let's make it a habit. T half চারটা or make it a table, that's also fast. Alright? কতক্ষণ গেল? 120 minutes, which is basically 2 hours. তখন কি কত থাকবে? 30. ঠিক আছে? So without background you will detect 30. How much will you detect if you consider background also? 50. So considering background your count should be 50. Alright? Does this make sense? So এরকম কোয়েশ্চনটা একটু ডিফারেন্টলি আসতে পারে if say তোমাকে বলা হলো যে the substance is 300 grams of radioactive substance. After 2 hours how much of the radioactive substance is left? ঠিক আছে? So after 2 hours মানে হইতেছে কতগুলো half life? চারটা half life. So basically 1/16. বাট এটা তুমি একবারে সোজা লিখতে পারবে না. বলতে হবে after 1 half life 150. After 2 half life 75. After 3 half lives কত হবে? 32.5. ঠিক আছে? তাই না? Did I say that right? No, I didn't. 37.5, right? তারপরে after 4 half lives কত হবে? 18.25. So yeah, approximately 18.25 grams or এরকম 18 grams. Do you get it? Clear? So yeah, this is how you do the calculations of background radiation. এটা গেল. তারপরে আসো তোমাদের next যে জিনিসটা দরকার is half life tough life নিয়ে decay curves and everything. Is everyone clear on this? All right, fine. Yes, বলো।
Background count, background radiation আসলে আমরা just normal half life করে দেব না? তবে যে background radiation না থাকলে যদি না
এটা না ব্যাকগ্রাউন্ড দেওয়া থাকবে আর ব্যাকগ্রাউন্ড না দেওয়া থাকলে গ্রাফের মধ্যে you're going to see something. What you'll see in the graph is a ভ্যালুটা এখানে যেরকম দেখাচ্ছিলাম হ্যাঁ এখানে কি হয় এটা কমে it starts to become constant at a certain value. ঠিক আছে এটা একটু উপরে উঠে যাচ্ছে এটা হবে না বেসিক্যালি it becomes constant এরকম উঠে তারপর এরকম ফ্ল্যাট হয়ে যায় when it becomes flat এর মানে কি এর মানে there's no decay going on anymore. ঠিক আছে that's basically background count. হ্যাঁ একটু fluctuations থাকতে পারে হ্যাঁ the fluctuation is because it is random and values মধ্যে হ্যাঁ এক সেকেন্ড 23 আসতে পারে next second 18 আসতে পারে next second 35 আসতে পারে আবার next second 12 আসতে পারে বুঝছো অ্যাভারেজ করে আস্তে আস্তে এরকম over 10 minutes অ্যাভারেজ করে তুমি দেখো যে 20 এর কাছাকাছি আসতেছে
so background radiation না দিলে তখন এখান থেকে আমি নিব
হ্যাঁ well sometimes you can do that আর আরেকটা হইতেছে ওই গ্রাফ থেকে কেমনে ব্যাকগ্রাউন্ড কাউন্ট করতে হয় হাফ লাইফ বাইর করতে হয় জানো তো basically you see the time তারপরে তুমি খুঁজবা যে কোন টাইমে গিয়ে এটা অর্ধেক হয়েছে then you do it a third time ঠিক আছে this is just to ensure that your calculation is correct তারপরে তুমি এই টাইমটা মাপবা right and you take two averages ঠিক আছে average করে তুমি দেখবা যে approximately কতক্ষণ আসতেছে as a background does this make sense to everyone all right well this is the simple basic stuff